Good morning, student. Welcome to my channel, The Science Station. From this video, I will explain the notes. As I told you before, if you want to write the notes, please check the shorts. So, without wasting any time, let's start the class. So, student, this is your first class, and your first unit is quantum physics and solids. As we know that we have an object. In earlier class, you come to know about the object having mass, velocity and time. With all these physical quantities, you can able to trace that particle. But just think, if the size of the particle is very small, so it is very difficult to know about that particle. That particle is having energy and all things, but it is very difficult to test that particle. So in quantum physics, we are dealing with such a small particle known as quanta. I will tell you before. So in first class, let's start with quantum physics. Now our question is, explain the significance of quantum physics. Quantum physics describes the energy levels and the bonding and electronic orbitals of atoms and molecules. It explains the molecular interaction in terms of electron distribution and motion. As this paragraph says, in quantum physics we are dealing with energy levels, because electron is very small, that particle is very small, we don't know about their uh, position, mass, but we know that particle is having some energy. So in quantum physics we deal with that small particle. It overcome the failure of classical physics to explain the phenomenon of photoelectric effect, black body radiation and the line spectra. These phenomena are explained using Planck's hypothesis and the wave particle duality. As I told you, quantum physics particle is little bit big. So we are not able to trace the energy of that particle. But this is the failure of quantum classical physics. Now come to the quantum physics. First topic is black body radiation. What is the black body? Anybody is having any idea? In easy term, I will explain you what is the black body. See, you have one football or a hollow sphere. We just cut the sphere like that. We have a football or ball. We just cut or make small hole and just color this inside whole black. This body, this is known as black body. I will read. A black body is an idealized physical body that observes all electromagnetic radiation falling on it and that radiates at all frequencies with a spectral energy distribution depend on its absolute temperature. I will explain you all this according to this diagram. See, already I told you this is the hollow sphere, inside we have black body. Suppose an incident radiation enters in it. Hit here, this radiation hit here, incident. This radiation or this atom, whatever we have, that lost its energy, again reflects. Come here, again lost its energy, again reflects here. So this process goes on. This is all about black body. Now we have laws of black body radiation. First we have Stephen-Boltzmann law. Stephen-Boltzmann law. When one question comes in your exam, explain Stephen-Boltzmann law. In 4 marks you have to write this. This law connects the intensity of radiation to the temperature. Means we are giving some mathematical formula between intensity of radiation and temperature. According to this law, the total radiation emitted from the black body at the temperature T is directly proportional to the fourth power is directly proportional to the fourth power of the temperature, that is T4. If E in energy is directly proportional to the T to the power 4. When we remove this proportionality constant, we introduce one constant, that is sigma. E equal to sigma T to the power 4. Again I am repeating, when we remove this proportionality sign, we introduce one constant. Here E equal to total energy radiant of black body, sigma, Stephen Boltzmann constant, T is the temperature. Sigma, the value of sigma is always 5.67 into 10 to the power minus at W meter square K4. This is your Stephen Boltzmann law. First law, it connects the intensity with the temperature. Stephen Boltzmann law gives the relation between the intensity of radiation and the temperature. Now next law is Weis displacement law. Again this law is very important when the examiner will ask a question in 4 marks. When 4 marks question will be asked, you have to write this. Now according to this, the peak wavelength lambda max. What is the wavelength? I will explain you. Wait. See. This is your wave is like that. Then this wavelength is known as peak wavelength lambda max. This wavelength is known as lambda max. The peak wavelength lambda max at which the maximum emission occurs for any given temperature is inversely proportional to the absolute temperature of the body. Lambda max is inversely proportional to the T, that is 1 upon T. Again, when we remove this proportionality sign, we introduce one constant, B. So lambda max, we have lambda max equal to B upon T. Lambda max equal to wavelength, peak wavelength, T equal to absolute temperature, B equal to proportionality constant. This law gives you intensity and absolute temperature relation. This law gives you the relation between the peak wavelength and T. Now, can you please tell me what is emission, or I will explain you. Emission means, the best example of emission is cooker. आप कुकर देखते हैं, कुकर गर्म रहता है, कुकर को आप गैस पे से निकालते हैं, रखते हैं, वहाँ से एक एनर्जी रिलीज होती है, गरम गरम वेव्स निकलती है, दैट इज इमिशन. नाउ थर्ड लॉ इज रेले-जीन्स लॉ. Third law is Rayleigh-Jean's law. It is classical law used to measure the intensity of radiation emitted by black body. You have to write as it is. In next Planck's radiation law, we derive this law. E lambda d lambda equal to 8 pi kt lambda to the power 4 d lambda. Or in the frequency, in the terms of frequency, we can write E nu equal to h nu h 8 pi nu square kt upon c cube. This is the E lambda. E lambda indicates the energy of that particle in lambda state, where E lambda is equal to emission power, K Boltzmann constant, lambda wavelength, T temperature. So we have 3 laws of black body radiation. First, Stephen Boltzmann law. Second one, Weis displacement law, and third one, Rayleigh-Jean's law. Now, one more small question I am telling you. Again, we have one question comes like that: what is a black body? State the Planck's hypothesis. When you have to ask question like that, what is a black body, you have to write this. See, what is the hypothesis? Hypothesis is not a law. Hypothesis means what we imagine, what we think about that, that is hypothesis. हिंदी में बोलते हैं अवधारणा. So black body, a body which observes, a body which absorbs radiation of all wavelength incident upon it is known as black body. It neither reflects nor transmits any of the incident radiation. Therefore, it appears black whatever be the color of the incident radiation. Therefore, it appears be the black whatever color of the incident radiation. As I show you, this is your black body. One incident rays incident on it, and it transmitted, again reflected, again reflected. Same thing I told you, the body which absorbs radiation of all wavelength. See, all wavelength radiation comes here, incident upon it known as black body. It neither reflect nor transmit. See, it is not reflect. When radiation comes here, it absorbs the energy and reflect here. Again it absorbs the energy and reflect here. Now Planck's hypothesis. Planck's hypothesis states that all electromagnetic radiated energy, all electromagnetic radiated energy is quantized and occurs in infinite bundle of energy known as photon. The quantum of energy for a photon is not a Planck constant, but it is the product of Planck constant and the frequency, E equal to h nu. This is the Planck's hypothesis. According to this hypothesis, Planck gives the law. This is very important question. In next video, I will show you the derivation of Planck's law of black body radiation. The phenomena in which light travels in the form of small discrete particle called quanta. As I told you before, in quantum physics, we are working on a small particle quanta. Planck's is known as Planck's radiation law. According to this law, we have u lambda d lambda equal to 8 pi hc upon lambda to the power 4 hc e lambda k bt minus 1 d lambda. So we have to write this. Now next question, derive an expression for the black body radiation using Planck's theory of radiation. The spectral energy distribution of radiation emitted by the black body is explained by the Planck's law of radiation. This radiation emitted by the black body is always explained by Planck's law of radiation. So, what is the Planck's law of radiation expression? The energy density of the heat radiation emitted from a black body at the temperature T in the wavelength d lambda to lambda plus d lambda. What is the energy density? Density means mass upon volume. So energy density means energy upon that available in that particular area, that is energy density. So according to this, the expression for Planck's law of radiation, we have E lambda, d lambda, 8 pi hc lambda to the power 5 e h nu kt minus 1. For if you ask to derive Planck's radiation law, you have to derive this. लास्ट में यही expression हमको आना चाहिए. In next video I will explain the derivation where h equal to Planck's constant, c speed of light that is 3 into 10 raised to power 8 meter per second, nu equal to frequency of radiation, k Boltzmann constant, t temperature of black body. In next video I will show you the whole derivation. First we have to derive this expression. According to Planck's distribution law, we have E lambda d lambda equal to 8 pi hc upon lambda to the power 5 e h nu upon kt minus 1. Now what is the lambda? What is the lambda and lambda plus d lambda? Suppose we have a function like that. We distribute, we cut the function in small and then we put the integration, we put the units limit xn to xn, that is. So ultimately we are working on, suppose we have lambda plus d lambda. So we are working on this part. Okay, here till here I will provide you notes through the shorts. If you want to write, you can check my shorts. So much, and like, share and subscribe the Science Station. Thank you so much.